So, long time no see, I guess. Another tutorial, basically the second part of the fractured stone architecture guide or tutorial or showing thing, I don't know, whatever you want to call it. And this is basically me trying to include all of those things that I've learned throughout basically half a year, I guess. I think this is when the last part was uploaded, or the last thing was uploaded. Therefore also including all those newer techniques and findings that I found, especially also throughout my bachelor thesis that I have finished 4 months ago actually. It's been some time. At the University of Innsbruck, Experimental Architecture Department, Studio Coletti, if someone is interested in that. Anyway, so I've been doing things, and I've actually found out, because I haven't opened this file in quite some time, that there is 2 things that I could cover today, and it really depends on how long it's gonna take me to do both, or actually this one, because I do also want to show like the rendering part of it, because I indeed got one question on Instagram. Feel free to follow me there as well and ask questions, or also ask questions here in the comments. By the way, this is just a process. I'm not saying that this is the best process or the most efficient one or the most whatever one. It's just the one that I figured out. So if there's something that you can add to this, something that you're suggesting others to do or me to do, please comment it down in the comments or tell me via some other medium. I don't know. But let's actually start, I think. So my mouse is a bit broken, so please bear with me. And you can't also see it, which is a bummer. Anyway, what I wanted to say is I do want to also talk about rendering, which I, for this part, or this one, actually did in Cinema 4D with Redshift. Most of the time I'm actually doing it in Houdini with Redshift, but sometimes there are just really big performance issues after all of those computing parts of simulations, or just the designing part in general, which leads to often having no VRAM left, and therefore I can't render and stuff. And because of this reason, I might actually do all of the rendering now in Cinema 4D. Also because for some reason I have a feeling that the quality, not necessarily the speed, but primarily the quality, is a bit better in Cinema 4D, even though it is the same exact engine. Anyway, I don't have to understand everything. So let's start with the Anfang, the very beginning, which is just one flat plane surface. And there's actually 2 ways to basically do the fracturing here. I'm doing the fracturing now for for some reason. I don't know. You might actually also be able to do so with a 3-dimensional object and not a 2-dimensional one. But anyway, so what you can be doing, and I'm just seeing whether I might have actually deleted like the first one, which is a bit of a bummer. Which is indeed a bit of a bummer, and was not really smart. I think the other one was lot subdivide. Yes, it was. Because with this you can do something like this. And it makes sense, or it made sense for me to have them a bit bigger and also cluster them in like 10 groups or something, so that you're not having that many pieces. On the other hand, you can also use a simulation, and or potentially also something like rainwater simulation and or sunlight simulation or a wind simulation to drive those the fracturing process, or basically splitting this one surface into multiple different ones. Therefore, I've also used a rather simple, I've also mirrored it apparently, particle simulation that is using this one line to project it onto this surface to then use it in this split node to split the surface into whatever many smaller surfaces, so to speak. What this is doing, or what is happening here, and my mouse is actually really broken. Anyway, I'm inputting this one line, and I'm making sure that, as you can see, oh, you can see my mouse. That is interesting. $big F, or uppercase F, equals 1, make sure that I'm only having one line, or that this one line is being used and not just a trillion lines, because I just only need this one line. I might also need 2 lines or whatever, but I could do this afterwards. Anyways, then I'm having this wind node, which is driving this distortion of the line, or this movement of the line, and then I'm having a subsolver. This subsolver is already raying or projecting this one curve onto the surface, as is used with this object merge node here. Anfang is actually the surface, and then resampling it so that I get even more points, or even more curviness, even more resolution, so to speak, after this one loop. And then it's being solved again and again, depending on the time that I'm giving it, as you can see here. Then I've decided for some reason to mirror it to gain even more fracturing points or fracturing lines. And what you could actually also maybe do is using a trail node, probably after this, and then accessing or gaining even more lines if you want to do so, with potentially also more distance in terms of time, and therefore also in terms of length, or lengthwise distance, by using this increment slider here. You might actually also do 100 or something, but this probably is kind of an overkill. So we might just stick with this one line and then mirroring it, and then apparently joining it so that I do have a closed line. Because apparently, I don't remember, but it doesn't like it to be an open curve. Then I'm raying this line once again onto this initial surface, and then splitting this this surface into into whatever many pieces that I get out of this, and then fracturing them. I don't know if you might be able to not use this one and only this one. Anyways, edge fracturing it with as many pieces as there are there. If I say it's just 2, there might be some problems. So I've probably said like could also do 400 in case there are even that many pieces, just to make sure that I'm gaining all of those surfaces that I could gain. Period. And then I'm blasting them into, well, basically different categories. There is somewhat of a remove me group for some reason, I don't actually know why. So that I get this one, and I'm also getting this one. Because I've decided to have different widths of those surfaces, I might actually use this one, just to keep it a bit cleaner. Sometimes with the simulation part, you might have to clean up those lines or those curves, or yeah. But you could also say, I think it is called draw a curve. Yeah, you could also draw a curve onto this one here, or it's actually wiser to select it and go to this top shelf here and then say draw curve actually, and then you could theoretically draw this curve, or you can draw this curve, and then you have a curve that you could also use by probably also joining it in some way, and then doing it like this, and then that, and then I'm blasting something away. And then we're having this many different parts here. Actually does work a bit better, just a tiny little bit. Probably makes sense to re-choose those in this blast. So let's say, okay, this is one for some reason. Let's actually use the more clean approach and do, we don't need this one then, I think. Yes, we don't. And then we are choosing this one and these, and then out of them we are gaining something like this. Of course, you can choose different groups, more groups, can change the whole other thing about it, whatever you like. And then I'm fracturing it again with this TED fracture, or it's called just TED fracture apparently. What is important here is that this path scale is quite low, because throughout the process I've seen that sometimes you have just one part of one fracturing part, so just the upper side or the left side or whatever, or surface as a group by itself or as a part by itself, which is something that we do not want to have. We just want to have all those bigger parts. So the left part here doesn't really matter. I'm gonna pull it aside. Then we're calculating the normal for some reason, I don't remember, and then what is connected with what, or just figuring out that every one of those is one part for itself, so that we can pull it apart, play with it, and so that it's not one single mesh. Choosing class, primitive, and integer, and then wholly filling something. Maybe there was some problem with it. I actually do not necessarily remember. Anyway, what we're doing here is making a VDB out of every single one of them. This is why we're also having this connectivity node, so that I can have classes, or that I generate classes out of this one piece of geometry, so to speak, and so that I can go through the pieces or points. So here the settings, and also using the class attribute, so that, as we can see, it's actually quite laggy. Nice. So that we have different VDBs created out of this, basically speaking, single object. And now the most important part, or the most interesting part, we are using those pieces, and we are moving them. Actually, kind of the worst piece to choose. Can I select just a different one, or we're just going to use this one? What we're doing here is, and there might be just a smarter way to do so or a more efficient way to do so, but I wasn't able to do it by using the copy and transform node. But we are first of all selecting all of those singular pieces, and we're transforming them by 0.7 in the x direction, so that there is a bit of a distance between the initial one and the now transformed one. Then we are copying it. Well, as we can see here, we are copying it. As I said, I wasn't able to do so with the copy and transform node for all of them simultaneously. And then we're merging them together to get something like this. The interesting part about this is we can also rotate it by like 2 degrees or maybe 5 degrees, which is then going to alter the way this cutting geometry is interacting with the initial geometry. As you can see with this VDB fracturing node, you might be able to see it. It's actually quite laggy, I'm sorry for that. But with this fracturing node, we can blast away whatever we have fractured. So this geometry here is just a cutting geometry, for this initial geometry. And yeah, as we can see here, we can also say maybe 10 degrees, and then after a bit of calculating, this is gonna change how it looks. We might also say 2, or we might actually also say 0. We might actually also say 5 here, which is gonna alter the whole thing, and move it a bit to the side, which might be interesting too. Then we also, and this is something that I think I didn't know back when I was doing the first part here, we also fracturing this wall panel or wall system with itself, so that we can gain a few, what the fuck do you call them? So that you gain a few nice lines that are then gonna cast some really nice shadows. Then we're gonna use the vdb reshape node with erode to get this effect. So when I go to 0, you see there's nothing, and then 1, there's a bit of a gap, a bit of a, I would say Fuge in German. What is this in English? I don't know. Someone might know, or you all might know. I don't know. And to just get a bit more detail, and of course you can choose a different geometry, a more complex geometry to do so, to just get more lines, and or you might probably also be able to do something like this. By the way, you can fracture it. The whole fracturing process can be done with a VDB, so pre-converting it into a VDB, or not, which is really nice because you get those really sharp edges, those really sharp lines by not using a VDB. So we might actually use a transform node there, and actually haven't used Houdini in a bit for reasons, and we might actually do something like 50 degrees and maybe 1.2 or something to just hopefully get a bit more of a of an effect here. And we do get some nicer lines, or we might actually do a 0 there and see what is happening now. And yeah, actually also looks quite good, I would say. So we're doing this, we're doing the fracturing, we're doing the reshaping, and then we're also doing another reshape. I guess might be the case that I've actually... No, we're actually doing it. I think I was trying a few things there. I was converting it, and then there is an attribute map. Oh, okay, I see. You can use an attribute map and then a soft peak based on the CD value or a color value to manipulate a geometry based on the texture that you're basically mapping onto it via this attribute from map node. Then you can generate a VDB out of it again. For some reason I was trying to use the density here, but normally you're using this. And of course you could definitely also use this as like your resulting geometry. But the problem here is, as you can see, it's just one VDB, and it's not all of those smaller pieces as a group anymore. And therefore I was apparently trying to do a bit of dilating. I'm sorry. A bit of dilating. But there isn't much of an effect, as we all can see probably. So yeah, it's just unnecessary at this point. It's just even better without it, because the edges are more crisp, and also those... I do want to know what this is called now. What is it? I don't remember. Anyway. And then we are converting it. We are converting it into a mesh again, from which node we can then export it with an ROP output, geometry output as FBX or OBJ or whatever you want it to be. And as far as I remember, when you are putting it into Cinema 4D and or Blender or whatever, you probably have those vertex colors already assigned to the geometry, to which is actually quite nice, because you can then assign different materials to all of them, as you were maybe able to see on my Instagram. Some of them are translucent, some of them are stony, some of them then have greenery or not, and whatnot. But I have decided to use this as somewhat of a building block, basically a facade building block or wall building block, like a wall out of blocks, and this one wall is also kind of a block, to then put it into Rhino. And when you're then using explode, you can actually again use all of those singular pieces again and delete them or copy them and whatever, because it was just an easier approach for me, and or faster approach for me, to have somewhat of an interesting composition by just copying it into Rhino and playing around with this whole geometry there. And this is actually quite it. I don't think that I've done anything besides that. I've been copying it a bit to render it like this. It's more of a wall-like thing. We might actually also, just for the sake of it, do it like this, and maybe altering the amplitude a bit, so that it's a bit of a smoother curve, a bit of a less overlaps. Did I want to do that? Amplitude, no, I don't want to change the amplitude. I want to change the swirl size. My mistake. Yeah, might actually be better. I don't know. I honestly don't know. I've mirrored it, I've joined it, and I've rated onto it, and then we are putting it into here, and then we are putting it into there. So apparently I do remember this polygon split is for splitting it, and this edge fracture is for then also fracturing this surface into those smaller pieces, because the split itself, I think, is just, well, it is actually also splitting it into smaller pieces. Anyway, I don't remember. I don't, yeah. As I said, it's been some time since I've actually also been using Houdini and been doing something. But it already actually looks a bit more interesting than the other one. These smaller parts might be huge problems, but we will see anyway. So let's let it compute, probably up to here, and let's see what this is doing. By the way, I'm not gonna give away the file to this project, because I don't think it is useful for learning this overall technique. Period, I guess. So yeah, just to be said. What we can see here is that maybe the transformation is not really sensical in this case, and we might do it somewhat differently. Yeah, of course you get all of those smaller pieces, which is not nice, but as I said, you probably have to use a better line, or draw the line yourself, or import a line from Rhino that you have pre-drawn or something. But yeah, anyway, a good way to get rid of those very small pieces is using this delete small node, and then I could probably also, nope, check. Let's see what it does, and it got rid of a few of those tinier ones. But yeah, for a real wall, something like this maybe might not make too much sense. But yeah, this is the overall process. And I do actually also want to talk about the other one. The funny thing is, I haven't used this in a post yet, And I actually forgot about it. I really did. But I do remember that it was quite the cool process and quite the interesting process, and something that I've seen on Instagram or whatever too. And yeah, let's see. Apparently, and this might be the reason why I didn't use it anymore. It's quite hefty. It's loading for quite a bit. It's nothing compared to my bachelor thesis, which was a nightmare in terms of computing everything. But yeah, I might actually do a video on that too. There was some sunlight analyses going on in this project too, which reminds me of, if you are trying to do some sunlight analysis, some wind analyses, some, I think there was a rainwater analysis, Tony, and I'm not going to butcher your name, Lee, on Instagram, just search for it, Tony Lee, who is teaching at the Bartlett, recently published some really interesting tools to do exactly that. And thanks, Tony, for releasing them so late. It would have been a blessing for me and my thesis. But yeah, it is what it is, I guess. And we'll let it load, unload. I do remember that I forgot about something. By the way, this is going to be a one take. And I hope that everything is working nicely now. What we are seeing here. I do remember, my God. For the wall part, I've just used an extrusion node to extrude them into different lengths. Those two parts that I've chosen. I think that I haven't gotten into this, unfortunately. So we're starting with the box. And I do see that we are not using the right wiring style. We're starting with a box, and we are bending this box and probably elongating it as well. Then we are vdb'ing it, and then we are fracturing it with a pop noise. I'm trying to go over all of those nodes. Yeah, something like this. Swirly whirly, as someone might say. And then fracturing it with the exact same basically way or approach as we did before. And then we can blast it away so that we have this. And then we can fracture it again by transforming it. Probably I've just rotated it a bit. Let's see. Yes, I did. And then we are blasting that again. And then we are fracturing it again with a mountainized version of itself, apparently, to probably, I don't actually remember why, but it might make sense in the end. So what is this one? We are merging those two and we are resampling it, because the thing is, when you're fracturing something, you cannot change anything about it with the transformation in terms of its scale. Especially, I think maybe only, but especially the ratio. So scaling the z-axis by 2 won't work. Houdini is going to say something like, yeah, basically you can't do that. And then you have to resample the overall vdb again so that you can indeed fracture it. We are doing this and we are blasting it away. We are fracturing it again. I'm just trying to see what I did there. And it might be the case that I've deleted something about it. I might be the case that I've deleted something. By the way, the clip node now is able to generate thicknesses, which is solely based on this thickness node. Yeah, by the way, when you're using preserved holes, I think, as far as I remember, or not using it, might also be the case, you do indeed get the thickness. If you're not doing so, you're not gonna get the thickness. But it's really nice to see that the clip node is finally giving me some thickness here. Really nice to see. But I do remember something that is also an interesting process or technique. We can vdb analyze it. At this point, I've did the Laplacian. Most often I'm using the curvature. And then we can reshape this given or this input geometry with this analysis as a mask. And as you can see, this is basically changing the edges of this given geometry. And apparently we're using one part of this geometry, so just this tiny part here and this one down there and a few of it, to specifically alter these. And then we are converting it. And then we're having this abomination of a thing. And then we're giving it a bit of thickness and then clipping it. And we're filling the polygons along the clipping plane too. So I might be doing this, and I've also blasted away some of it. And then of course we're losing this infills. But I do remember, unfortunately, it's been some time, but I do remember there was something about this overall process, besides being able to directly change some parts of a geometry, that we have, by the way, achieved through this fracturing process. Let me see. There was actually something really interesting about that. Interesting in terms of I might actually need this thickness too. I might need this thickness, and it was 0.75. Maybe there was something there. Because I do see there is nothing, and there is like a clipping surface. And then we are... It's actually kind of a pity now that I do not remember what I did there, or what was the interesting part about it. By the way, this VDB segment by connectivity is really useful to be able to delete those very small pieces that are just flying around and do not make sense for architecture related designs. And then we're doing this, and then we're doing that. I do not actually see VDB from polygons. Fill interior, preserve holes. I don't want to change like the initial parts of it, because it's gonna load for like half a year again. But I think the overall learning from all of this is, first of all, you can VDB and fracture and change already fractured geometries by also specifically choosing a group or just a surface, as we can do in this drop-down menu, that you maybe can't see. Yeah, you can't see. Anyway, you can use it. And we can use non-vdb'd things. Blasting this away. Why did I blast this away? I mean to get rid of it, yeah, of course. But we could definitely also choose nothing here and or just this one. And as you can see, now not only this part, but we do have something happening on the the other part of the fractured geometry, and then converting it again. Probably it might be, I didn't even. And then giving it some thickness to, okay, I see. I've given a different thickness apparently to, yes, to this surface. So I might be able to blast them away. There's a different thickness to this surface than it is to this tiny pieces of surface. Which I might be able to make bigger by maybe not offsetting it or dilating this whole thing by so much, or maybe get a bit more of a resolution here. Let's see if it is more. Probably not. And I do, by the way, hope that the audio is fine, especially while it is computing, because it might not be too nice. Yeah, we do have more now. Nice. So we are assigning different thicknesses to both geometries, and I hope that now it is a bit nicer. And this leads to having a different thickness here, as we can see, and a different thickness in some other parts of the geometry, which can be really nice and really useful and really important for some models. And then also getting rid of all of them. Sometimes it's a bit of a pain in the ass, as we can see here, which is just glitching around. But one can generate quite interesting sectional tests, interesting sectional models with this process of basically fracturing a rather simple cube with a more detailed geometry. And then you might actually also do like a blur or something. Attribute blur. Oppa, might be interesting as well. Or you might actually do it beforehand. Let's see. To gain a bit more fluidity. Unless, I mean, this also looks quite interesting, has something, but might be cleaner in this way. And let's see what this is now doing. Yeah, might be a bit of a cleaner approach. I don't know, depends. Really depends. You might be also subdividing it again a bit more, but I think especially these parts here can be quite interesting if used correctly and or in a way that you can actually also use it. Which reminds me of conversation that I've had during my thesis, where I've been actually doing quite a bit of sectional modeling, and the process wasn't really clean, and it looked cool, but in the end it was just quite not unnecessary. I think there's always somewhat of a learning, but I think there isn't that much you can use something like this for, at least not immediately. There has to be some work put into it to make it usable. But it is interesting to see that you can have different thicknesses, and also interesting like moments like this here, where those two geometries are kind of in line with each and another and create interesting compositions or relations to each and another. We might actually also just transform. Should I? Yes, I should. No, I shouldn't. I should have not, or something. But I think what was actually really important, there was something really interesting about this preserve holes with the VDB. That might be convert, that I've actually forgotten about now. I would actually start with those settings that I've shown you now, with nothing checked, or fill holes. Because one of those was the reason why there wasn't an inner side of the VDB then. I do remember. And we might just check this really quickly. So we might do a box now. Please just do the box. Thank you. And we bend it in some way again. We bend it in some way, something like this, and we're probably gonna give it like 20. Bending it a bit more by 200 degrees. Yeah, maybe, I don't know. And then we're giving it a thickness. Oh, we're giving it a bit of, maybe I shouldn't do that. Maybe it should be not 200 degrees, but like 80. Yeah, we're giving it a thickness, and then we have VDB from polygons, and there is nothing checked. So we're doing this, and then we're gonna convert the VDB into, no, doch, we're gonna use this to polygons again, and then we are clipping it. And when we're clipping it, we can see there is nothing in there. So the thickening was actually useless. But when we are serving holes, we get this thickness, which is really important, because if I decided to give this a thickness, it would alter how this geometry is working completely, and or by giving, like, because of this, just I'm preserving this inner part. Yeah, I'm not gonna have problems with it anymore, especially also when I am doing maybe a mountain in here. I'm gonna keep like this different widths, which might be really nice for a few projects. Maybe not that much, maybe something like this, and probably also having a higher resolution, probably a really high resolution of a model, and probably also a higher resolution of initial geometry as well, and probably also like something like this. Yeah, which might be quite of an interesting approach or way or whatever. So we might actually fracture it for just the sake of it, like this, and we are using that with a transform node to everything set to none. That is nice because I do not need any visualization that I could do with this or that. But the problem here is, of course, that I do have to change something. I do wanna rotate it pieces. Have I changed anything about? I should have a color here, a red one. Oppa. Yeah, I might have broken something. Connect by split. Yeah, anyway, I mean, you get the point. And then, of course, when you're using the reshape node, and we are reshaping it by eroding it, we get those nice Fugen, whatever, and you might actually also destroy the complete thing. So there's always a bit of tinkering and making sure that the overall system works. And then we are doing this. Yeah, there we go. For some reason, yeah, anyway. And we might actually do 0.1, something like this. And then when we're clipping it, we're having this nice gap. Do I want to call it gap? I want to call it gap now. We're having this nice thickness. We might actually do like 0.2 of a reshape just to get this initial part here. And of course, we might actually also have this here and merge it, actually combining it with this one that we have also rotated via that degree, and then we're gonna choose, I never know, maximum, I guess. No, it's not. Minimum. And then it already says some grids were not processed because there were more A grids than B grids. Which actually doesn't make much sense because it's just one grid. Oh no. Because it wasn't vdb'd. vdb from polygons. And what is also interesting here, so now it works. What is also interesting here, that first of all, we need to preserve the holes again, and the lower res to the higher res. And then we can fracture it again and see what it does. Of course, it's creating a different scene. And now what we're having here is that something doesn't work. Nice. Did I use the correct settings? Preserve holes. Preserve holes. We might actually need to do this as well. Maybe also the clipping is just too far. 0.5. Yeah, because there is nothing. Apparently 1.5. Okay, apparently might be because of the combine, but for some reason, could this be? No, it doesn't make any sense. Probably because of the combine. We could actually have a look at this or into this. What if we just choose add? Yeah, nice. Amazing. SDF union. Yeah, but might actually also be really interesting because you're still having this tinier room here. It might actually be nice that it is not working or something. And then once again, we can also reshape only one of those. For example, this one, dilating it by a bit. We might actually use the one because it's, yeah, by 5 or something, and then we're converting it. But as far as I know, as long as it is not 1 vdb, because you could also say, which might actually be smarter, you could say you're doing both of them, but you're still having like this issue then, apparently. But we can use a blast to just have this 0, which is also interesting. All this fracturing can actually get some really interesting fragments, or can generate some interesting fragments, and then using it as a mask, which might do the same, which doesn't do the same. Which doesn't do the same because maybe we have to use the 1 and then 5. Yeah, it doesn't do anything anyway. So the point is, once you have fractured something, you can still manipulate it. You can still add actually also noise to it. Volume noise. I don't know if this works like this as well, which is really hefty in terms of computing. We're just gonna increase, no. As far as I know, it's just working with vdb, but a fog vdb. As far as I remember, I might actually also be mistaken, and I might have been mistaken. Or we just have to choose one of them. I might be mistaken, or you just have to calculate it from the get-go as a fog vdb. But anyway, so can I actually pause the recording? No, I can't. So I think this is the one process. Also why I've said initially that you could probably also start with a 3D geometry and then fracture it afterwards, which might give you more interesting parts, and then use those fractured parts as a cutaway geometry as shown in the initial one. But I think the approach in the wall design was starting with a surface and then being able to draw wherever you want to have a hole, because it might be some translucent or some wall with vegetation on it that is actually in front of the real facade of the house itself or whatever. So yeah, different thoughts, different ways to do things, and also this overall approach as a preserving holes, creating holes, having different thicknesses, which by the way you could definitely also do here, which we might actually also try. Should we try? Do I want to try? Yeah, I mean, choosing different thicknesses for both of those. We might actually also, you probably could also fracture it with the other technique, like having a line and then splitting it and then having different thicknesses on both of them to then yeah, have different wall strengths in them. You might actually also thicken. What if I thicken them? Ah, yeah. Okay. This is probably also why I didn't want to have those there. And probably 0.02. Something a bit smaller. Yeah, so that I do have cavities basically. Let's see if I can have just those. No. But I guess that I could blast. That I could blast this and okay, I see. Unfortunately, it's one whole thing, but you could probably also Boolean intersect them and then loft them, or just probably also just making a section cut in another software. But yeah, one can get some more interesting more interesting sectional situations here. For example, I think we'll get into the rendering now that I, as I said before, have done in Cinema 4D with all of those materials that I've used and the settings that I've used, and the diagram, the pseudo diagram that I've done by just using the newly introduced toon shaders and so on and so forth, which actually worked out really nicely and was quite a bit of fun to do. It always takes a lot of time. I always wish it was a bit faster, and I've also used Keyshot previously, which is actually quite great for various things, but in the end you can also use Blender. In the end you could also, I don't know, I've tried all of them, real time, non-real time, quote-unquote professional ones, open source ones, really doesn't matter. Let's actually get the right one there. Should be fine, and yes, it is fine. There we go. Let me see if I can get that. There we go. There we go. Nice. So the general setup is I'm basically having this one dome light with this texture map here, and that is quite it. I've been using lights and whatnot, but I want it as fast and as nice as I can, and therefore I decided to just use this one dome light, and it gets everything done. You can download them wherever. You can also use a different one, and so on and so forth. Oh, oops. And this is the quote-unquote final model that I've then done in Rhino with those building blocks, so to speak. And let me actually just close Houdini there. Yeah, save and quit. All good. And yeah, in Redshift, can I show you? You don't see it. Just in terms of the render settings. Fuck. This would be a bummer. I can show you this. There are render settings. Okay, yeah, better than nothing. So what I'm always doing is not using automatic sampling. It always takes way too long, and most often 256 or 3. What's the other one? Is it 312? Yeah, it's always by 4, you know, the trick and whatnot. Then Gaussian, but 1.5 or 2 as a filter size works really well, and then denoising it with Oiden or the Intel denoiser open image. No, it's open. Yeah, you know what I mean. Anyway, then for the globals, I often really play around with them, but I think most often it's just gonna look worse then, so just let it be. And unless you're not having any transparency or you're not having any reflective surfaces or any volumes, actually this I don't have, then just put it to 0 because it's unnecessary. Brute force 4, and this is like what it was. Very often I'm just doing it to 4. My bachelor thesis, it was actually like 2 and 2, and I think no caustics and the globals, everything on 3 or something, so just really low render settings, because it was such a pain to render, because it was so big, so many textures, so many things. Like the biggest part about it was getting it to work and trying to figure out a workflow to do so, which in the end I have to say was really unnecessary. Anyways, using 512 as a bucket size, and actually, by the way, 512 for the sampling also works really well. This is what I meant before, and then spiraling them. This is basically what I'm using, and it works fine with this one this one, say it, dome light, yeah. For the post effects, what I have figured out is I'm having a white background in render, because I just want to have a white background. Flare, bloom, and streak, sometimes I use them. I find them quite nice. Then also adding 0.05 of contrast, because, and you can't see it there, but in the render settings, just because I want to have it fully white, I have to use the unmapped mode in terms of tone mapping. Previously, I was using a white image as a background there, which was not affected by the tone mapping. For some reason, the white automatic like color, background color, is affected by the tone mapping. Therefore, I have to use the untone mapped image processing way or whatever, and then color grading it a little tiny bit. The material override is just used for the toon material, which was the way I did this diagram. And I can show you now, window capture, Cinema 4D, there we go. This toon map that I've used for the diagrams. The first one with two side models of other houses, just to make sure that people understand how it looks besides other houses and whatnot, is just using a ramp that is just white, then a distorter that is actually not doing anything, and then using a contour. And this contour is set to separate all the meshes. And because all of them is a separate, you can't see it. You can't see it. I just realized you can't see it. Okay. But soon you can. Node editor. There we go. Nice. Having this contour on black and black, you can also use some other color, whatever you want. And it is automatically separating all of those building blocks into separate meshes, and therefore creates an outline on these meshes. And this essentially creates this very diagrammy look. Recently introduced are also something like tone map patterns that can be set to syn waves or halftone and whatnot. I don't fully understand it, therefore I also do not really use it. And yeah, that's it with the diagram actually. Then moving to the glass texture. Can you see? Why can't you see this? Why is this gone now? There you go. This brick, can you see? This is just a brick texture. It's just a few lines. Yeah, that is set up like this, and this refraction transmission values just create this blocky glass feeling, which I've really enjoyed for this render. Then for the soil, I didn't use the soil in the end anyways. This is probably the most complex one, where I've used different bump maps and displacement maps to create this more organic, also partly greenish color in based on the curvature. Yeah, just have a look at it, do it the same, do it in a better way. Basically the textures that you're using, just download them somewhere. You can see it's a brick. Also the brick height map. There are so many PBR materials that you can find online anyways. Just go for them. And also another one, I think this might have actually been the greenish one. Yeah, all of them are basically built in the same way, as well as the last one, which probably is the wood one, It's even simpler, just the wood and the bump map. And then playing around with the light and trying to make sure that everything is fine. And I think that this is actually, I'm not going to run the rendering because it's not going to work too well. It's going to be pretty slow and maybe even crash my PC. And I do want to keep this recording. It's really important. But I think that is quite it. And then just searching for some good angles. The matrix. Oppa. The matrix. There we go. As you can see, this is where the vegetation was, and this was by using a plane and a random effector. The random is, can I open it like this? Yeah. Rotating those plants by 90 degrees and also changing the scale that I've then also changed down there. But also using the plane because it does create, it's going to the plane, and then also using a random field on the plane to as you can see, just have a bit of a more gradient-like displacement and movement and placement of those plants there. And you can color shift it and do it randomly. You can do it based on noise. You can do it apparently sorted, global and field, and then choosing like Voronoi. Maybe don't use Voronoi. Electric. And yeah, as you can see, it just looks, at least at my point of view, a lot better than, than something like this. When it's everywhere, you can also just not use it because it's gonna clutter all of it and you can't see the geometry anymore. But by using something like this, you can still understand the geometry. You can still understand like this beautifully crafted thing that you have done. And by doing something like this, nobody can understand it, and all of the modeling that you've did or assembling that you've done is yeah, for nothing. And yeah, I think this is it. Sometimes I've used the physical light. Yeah, just one light, and that is actually quite it. If there's anything to ask, please ask in the comments, and I'll hopefully see you next time. So bye-bye, and shout out to the University Exp-Arc team. Check them out. Maybe apply for this university. There is many students, so I don't know if this is suggestible. I think it is. Yeah. Anyways, see you.